Hi, in this video I will show you how to make a wireless charger for this electrical scooter. I'm sure many of you have the same problem with this scooter. Is when the battery below 50%, the performance drops a lot, especially when you go uphill. So you will have to charge it very often to keep the same performance. But charging this scooter is not hard, but it can be really annoying and boring, especially when it's covered with mud or snow. And also the charging port is at the bottom of the scooter, so it's kind of difficult to reach. Therefore, I decided to find a new way to charge the scooter by wireless charging. So the idea is very simple. I like to have a charging mat like this, a very flexible and thin charging mat to be placed underneath the scooter, and also a receiver, a wireless charging receiver to be placed underneath the scooter, and also very easy to install. And with this setup, you can just park the scooter above this charging pad and it will begin to charge. So a very elegant solution compared to the typical cable charging. So it sounds very easy, right? But before we do any real work, we need to know that if such a solution is viable or not. So the first thing we need to do is to run some electromagnetic simulation to find out the magnetic link between the transmitter and the receiver. So by using some software, we find out that the coupling factor between the transmitter and the receiver is about 8%. This is actually quite low compared to the typical mobile phone wireless charger, which can be easily over 50%. However, this does not mean that it's impossible to charge this scooter wirelessly. We know that the wireless charging efficiency is proportional to both coupling factor and the Q factor. So even at a low coupling, it's still possible to have a high efficiency by increasing the Q factor of both the transmitter coil and the receiver coil. Therefore, by some calculations, we find out that in order to have a reasonable Q factor, we need to have a frequency more than 1 MHz. So here we choose 6.78 MHz as our operating frequency. This is because it's in the ISM band, so it is free to use. So now with the frequency decided, it's time to run some circuit simulation to see if we can achieve the charging voltage and the current for this application. And also we need to decide what type of inverter topology we need to generate the alternating magnetic field. The easiest inverter topology is the H-bridge or half-bridge inverter. However, this kind of inverter topology is usually hot switched, which means a high switching loss. And it may be okay at say 100 kHz, but at this high frequency, this switching loss will be very significant. Therefore, we decided to use the Class E inverter, which is designed for high frequency operation. So by running some circuit simulations, we found out that it's possible to output 42 volt and 1 amp with a 42 volt input at the transmitter side. So this is actually perfect because we can use the original scooter charger as the power supply to this wireless charging pad. And the efficiency is about 75%. This is actually acceptable because with a 70 watt input, we can get about 50 watt output to charge the scooter. It's a little bit slower than the original scooter charger, but this is actually acceptable. Okay, so now with the simulation stuff done, let's go make the real thing. The first thing we need to do is to design the transmitter PCB and the receiver PCB. The transmitter contains the inverter circuit and also a microcontroller to generate the 6.78 MHz PWM signal. Receiver contains both the receive coil, a rectifier, and also a DC-DC converter to generate a stable 42 volt output. Okay, now we are waiting for the PCBs to be manufactured. Let's print some enclosures for both the transmitter and the receiver. Now we have received the PCB, let's assemble them. It's actually very simple. For the transmitter, it contains only a few parts, and the receiver is even easier because the coil is integrated in the same PCB. So we just need to put them in a plastic case. So now we have a complete wireless charging system. Let's test it. So first, let's use the electronic load to see if we can get the correct output voltage and the current. Okay, so it works perfect, just like the battery charger. So now let's go test in real life.